Okay, I think that we can start. Hello and welcome everyone to this series of webinars. And today we have the first webinar of the series of 6 ones. My name is Maria Mishevska, and today I have the honor to also have with me here joining our expert, Cengiz Kurtoglu.
Thanks a lot. Welcome. Hi, everyone.
Hi again, and now we're going to move to the agenda of the webinar that we're going to talk about today. So first of all, as I mentioned before, welcome everyone. So nice to have all of you join us on the webinar today. We're going to have a brief overview of the key insights and knowledge you'll gain on today's session. We're going to talk about the collaborative partnership between Knowledge Point and Autodesk, exploring the synergies that drive our shared objectives. We're also going to have our featured expert, who he shares valuable insights and expertise in the field. We're going to explore the capabilities of Autodesk Fusion software and discover its transformative impacts on your work. Also, you're going to get a sneak peek into our upcoming webinars, offering a glimpse of the exciting topics and speakers awaiting you. We also value your engagement, so you can reach out to us, ask questions, and share your thoughts. Your feedback is essential to our continuous improvement. Thank you all for being with us today. Let's embark on this knowledge sharing journey together. Without further ado, I would like to introduce myself. So my name is Maria, and I'm delighted to welcome all to you to today's webinar, which is called Fundamental Mechanical Part Design Techniques with Fusion, specifically unveiling the creation of a robotic arm mechanism. In this webinar, you'll have the chance to discover essential mechanical part design methods. Through the illustration of a robotic arm mechanism, we'll demonstrate how Fusion can be applied for designing, modeling, and creating product concepts. A little bit about the Knowledge Point and Autodesk partnership. So, celebrating over 25 years of excellence in the learning industry, Knowledge Point proudly serves as the exclusive distributor for Autodesk Learning Partner in the EMEA territory. Our extensive service offerings encompass print and digital services, channel services, and administration and business support. The strategic partnership between Knowledge Point and Autodesk is a testament to our commitment to providing top-tier educational resources. As Autodesk learning partners, we are uniquely positioned to facilitate the development of vital skills needed to leverage Autodesk technology. Autodesk, which is a global leader, is revolutionizing the way the world approaches design and production across diverse sectors, spanning from architecture and engineering to product design, manufacturing, media, and entertainment, thereby empowering innovators worldwide to address challenges, whether they are large or small. Now, I would be thrilled to introduce our industry expert for today's webinar. Please all give a warm welcome to Cengiz Kurtoglu, who is a mechanical design engineer with extensive training experience in both Knowledge Point and Autodesk. Cengiz?
Thanks a lot. Thanks a lot, Maria. Hello, everyone. Welcome to our first session. I will try to share my screen now to present a quick introduction to Fusion 360. And after that, we will see some details directly in Fusion 360. Now I'm sharing my screen. Yes, I hope you will see the session. Well, today, the session will be about the fundamental mechanical part design techniques in Fusion 360. My name is Cengiz, and hello again for everyone. You can send some comments or questions in the session. We will discuss about end of the session in details. And about me, my name is Cengiz. I've been working with Autodesk as a Autodesk authorized instructor about 6 years, and I'm a mechanical design engineer. I also finished my master degree in INSA and Acıbadem University as a mechanical design engineer. And I'm located in France, Paris. I'm originally from Turkey, Istanbul, and I have a social media account, Design Wagon. I'm sharing some details about the 3D design, mechanical design, and all interesting stuff about the 3D design. So today, the first webinar in our webinar series, we will start with Autodesk Fusion. What is Autodesk Fusion, and what is exactly what different types of workspace is working on the Autodesk Fusion. And today we will discuss about the CAD modeling, computer-aided design modeling workspace. And I will share some projects using direct diffusion, creating a slide joint part and spur gear mechanism. And we will see and creation and modification of a robotic arm mechanism assemble, and also different assemble types of mechanism. So before to begin the Autodesk Fusion, if you have any question about the presentation, you will send a quick question for the comments. In the end of the presentation, I will try to discuss and answer to those questions. So, well, what is Autodesk Fusion? Well, we have a quick poll about Autodesk Fusion. If you ever use the Autodesk Fusion, you can just answer the poll. I just want to get knowledge about your experience with Fusion, because we will try to create a session about the modeling techniques, which is important for creating different types of projects in Fusion. So if you like to answer the question, yeah, now I'm seeing the, well, in around 50-50, it's 43, I never used it, and I have a basic experience, 30%. That's great, because we will see in details. If you have no prior experience, it's okay, you will be welcomed. And if you have a advanced experience about Fusion, you will have a chance to get some tips about the designing new tools directly in the software. Well, Autodesk Fusion as a design workspace, it all starts as a design CAD modeling. You can design basically use all different types of CAD tools like extrude, loft, or revolve in the solid modeling workspace, like this table-wise, or just another robotic arm, or different types of details in the form modeling, T-spline modeling. You'll have a chance to create all of it in the design workspace. The important thing is that all suitable shapes model be automatically converted to solid models. Additionally, if you are a 3D printing enthusiast, or if you like to create different types of different types of CAD models, you'll have a chance to manufacture it directly in Fusion 360. And there are some different workspaces: render workspaces, technical drawing workspace, or simulation analysis workspace in Fusion 360, Fusion directly. But we will start with design modeling. Well, today in detail, we have a project about creating a robotic arm and table-wise mechanism. I will show you in the lately presentation. Also, there are different types of modeling techniques like create form, T-spline modeling. As you can see, this glasses, it's T-spline model because there are some different approach to create 3D models. Well, also you have a chance to create surface model directly in Fusion. After that, you can manufacture it because in the automotive parts or different types of manufacturing software, they'll need to surface model. Also, in the lately years, there are some 3D scanner. 3D scanners create 3D models directly as a mesh. Well, in Fusion, you'll have a chance to modify or create some mesh tools directly in the design workspace. And also, if you like to create sheet metal rules, you can find all details of the sheet metal tools in the design workspace. Well, there are another workspace which is quite important to project your 3D models as materials, as appearances, because, for example, the projects should be presented to the jury or the universities, academic staff, or the companies. Well, after you design a project in Fusion, you can switch the workspaces. In the render workspace, there is a chance to create these renders using cloud systems. Well, what is cloud system? It's normally Fusion directly use the internet connection, web connections, to create, actually to use your projects to calculate your render image process. For example, if I use my computer hardware to create these renders, it'll much more time to calculate these renders. But with the cloud render, for example, in the middle of the wall clock, normally it's around the 6 hours to create high quality image render with my computer. But with the cloud renderer, it will finish in 30 minutes, really fast. And after you send your projects as a render processing, you can continue with your different projects. It's really profitable for around the time, around the different continue to your different projects. Well, also there is another workspace as animation. For the large scale of projects or products, promotions, we always want to design and promote our projects. Well, in the animation workspace, we can do quick camera animations, or we can use the auto collide to auto explode tool to create these types of animations. And also, I generally prefer to use a motion study in the design workspace. We will be discussed in the software session. After you create and modify your joints, you can create different types of motion study like this one. Well, it's very handy tool, and you will use these types of motion study in the render workspace also. So with the animation workspace and the motion study, you can create different connection between the all 3D models and your projects. Well, another important workspace, which is we will be discuss in our next webinars, simulation analysis. Well, in the Fusion 360, in the Fusion, you'll have access directly to the different types of analysis tools, like static stress simulation of a robotic arm gripper holder, or topology optimization, or thermal stress, or directly to get knowledge about the nonlinear static stress analysis. Well, which is quite important to get knowledge about the load, constraints, materials, in the conditions, as we are engineer, it should be all projects pass the simulation points, because if you change the materials, or if you modify the design process in the manufacturing point, it will change all the process. So, which is very important to get knowledge about the simulation, static stress simulation. We will have a chance to discuss about these types of projects. And also, you can use the shape optimization, or topology optimization is widely used to optimize your, or lightweight your parts. Well, in the automotive industry, or different types of industries, lightweighting is very, very important process to get weight reduction in our parts. Well, you'll see some projects like generative design, which is quite new tool in Fusion 360. It will use artificial intelligence, AI-powered process to create our new parts directly in Fusion. Well, I'll show you some other examples in Fusion 360. Well, manufacturing, there is two types of different manufacturing, which is quite important in Fusion, like milling or additive manufacturing. Well, the industry level, it's very common to create your parts, to manufacture it. You can use the milling tools, like CNC tools. Well, in Fusion, you have a workspace you can create G-code directly in manufacturing workspace. Well, after we design a tool or a project, I will switch to manufacturing workspace, and you can create your parts to manufacture it with your 3D printer or with your CNC, which is quite large library. It will exist in Fusion 360. Well, in the other drawing workspace, it will also important to use the drawing technical drawing annotation in Fusion, because likely you can use your 3D printers to manufacture your parts, but it's very important to send some knowledge about your parts to other partners. Well, in that way, in the industrial level, we will use these workspace to send some information about our parts. Well, the dimensions, the material list, or the surface condition, which is quite important to manufacture your parts. Well, on the other hand, you can create your parts as a technical drawing, as a PDF or DVG. You can use in the AutoCAD, which is well-known product for create some technical drawings to modify it. Well, it's very convenient to create your parts if you are manufacturing your 3D models. Well, for me as a mechanical engineer, in some our projects, we used 3D PCB workspace in our team. It was totally connected to engineering teams. Well, it was fast and reliable to up-to-date the formats between the teams or projects. You can create the PCB schematic, library management, simulation, mechanical design in the Fusion 3D and Fusion 3D electronic design workspace. Well, normally it's quite changing the way to create from zero to end of the manufacturing the 3D parts. Well, normally if you are creating a project or we can some explain it in projects as a air quality sensor. Well, normally you can use your electronic design to create your PCB parts directly in Fusion. After that, at the same project, you'll have a chance to create your 3D parts directly in Fusion, and at the same time, we can connect these parts in 3D design workspace. Well, on the other hand, there are another workspace, which is my favorite workspace, generative design. Well, generative design is a process of design exploration. Designers or engineers enter design goal to create their parts to the software, along with the parameters such as performance or some requirements about the materials, manufacturing methods, or cost constraints. the software explores all possible permutations of a solution. Quickly, generative design alternates different types of 3D parts. It tests and learns from each iteration what works and what doesn't. After that, it will send us different parts at the same time. Now we can compare it, we can select and modify directly to the design workspace, which is quite important, and we will discuss it in our next sessions using some drone concept chassis creation or robotic arm gripper holder using generative design. Well, there is second poll about in our presentation, which workspace interests you most? Design, simulation, generative design, or electronic design? Well, if you have any question about the presentation, you can send me some comments, comments from directly to question part, and I will switch to Fusion to explain some projects. Well, design workspace mostly, and electronic design, which is quite important also. If you are interested on electronic design, you'll have a chance to create different types of PCB designs directly in Fusion. Well, today we will continue as a design workspace CAD modeling. Thanks for the attending the poll. Well, let's learn about the modeling techniques in Autodesk Fusion. Well, first of all, you can use Autodesk Fusion directly in fusion.online.autodesk.com. You don't have need to download, or I already downloaded, but sometimes I just need to check some projects quickly. Well, I'm using the web browser, which is working quite well to create, also modify your parts. Well, this is an interface of Fusion modeling and design workspace. I would like to explain it directly in here. Normally, you have a 9 square icon in there. If you select this icon, you can show your all projects in Fusion. If you like to learn or just quick looking at your parts, you can select design samples or the electronic samples, which is available in Fusion. You can go check, and you can use these parts to get knowledge about these projects. Well, all Autodesk softwares, there's a same logic to start your first parts. In the design workspace, you can start with the solids modeling, which is quite important to start with the sketch. If you want to create a sketch, you can check on the create sketch. After that, you can extrude it, and you can revolve it. Well, normally the logic, the approach of the creating a new parts, we will start with the left to the right. Now we have a create session. We have a create session and other parts to modify it and to create some assemble in the same workspace, design workspace. Well, after that, you can use browser parts in that. There's some folders to create your bodies, sketch, construction. We will use in our examples browser, and in the below there's a timeline. Normally it'll start with 0. For example, I already create a sketch after a extrude, sketch, extrude, etc. You can always return back to modify these parts, and some feature will be you can change some features or suppress some features to modify your parts from the timeline. And right top of the view, there is a view cube. It's very handy to you can use or directly. I generally use the mouse to manipulate, to orient my 3D workspace. And also at the top of the right corner, you can change your preferences or profile accounts to get knowledge about your detailed preferences in Fusion. And below, you can change your view details like pan view, zoom, or grid settings using these icons. And also, normally, we just look at our design workspace. Well, it's right up there. It's written solid workspace. You can change your workspace as in the design workspace. You can change the tab like surface, like mesh, sheet metal, plastic, or utilities. To use these parts, it's very handy. It's not, for example, you can create your parts as a analysis tool, static simulation parts, but you need to change your workspace. Now we are starting to create our parts from 0 using design workspace. If you like to change your workspace, you can use this icon like design. If you select that, you'll have a chance to see generative design, render workspace, animation, and all others. Well, now I would like to introduce some projects from Autodesk Fusion, a table-wise animation. I already used motion study to create this animation, well, which is quite. It's not difficult to create these projects, but it should be important to design it at the same workspace. It will be much easier to assemble it after you create these parts. Well, we will see in the Fusion these projects. I will switch my screen to Fusion. Well, as you can see, in the 3D workspace, I can change modify, manipulate the parts, because the parts, it's already joint. I used the joints to create these parts, these projects in the table-wise projects. Well, I will show you the motion study to just quick introduction before I start to design parts. Well, as you can see, there's a slight joint to manipulate the parts in the Fusion, which is will be used in robotic arm, but it will be a revolve joints. I will come back to my presentation. Well, there's a quick explanation about the start a 3D design in Fusion. Well, normally I would like to create these parts in Fusion right now. I can start with creating a sketch to design these parts. Normally, you can use same sketch to create these parts. As you can see, the slider parts, it will be slide in the second part. There will be two different components, but we can use same sketch to create, to design these two parts. I will show you. Normally, we can start with create a square in the sketch workspace. Then I will use an offset. Now I will switch to Fusion and create a new parts from beginning. If you want to switch off your layout grid, there's a icon, grid settings. You can deselect the layout grid. But well, normally I will use the layout. Now, as I already told you, I'll start with create sketch. Now, Fusion asked me to select a plane. Well, how can assign a plane to knowledge about the which parts X, which part Z, and which axis Y? You can use this view cube. As you can see, the red one is X, Y, and Z. Well, I will select a XY plane to start our first parts in Fusion. Normally, you can use different approach to create these parts, but I will start with rectangle because I need to create a square. Normally, if I select 2-point rectangle, it will start with 1 point to 1 point to create a rectangle. But there's a feature options in there: rectangle, 2-point rectangle, 3-point rectangle, and center rectangle. Well, I need to use center rectangle, which can be create a square, and also I just want to place my center point directly to the origin. Well, I select it, and now I created a rectangle with no dimension. If I select D, or in the create section, sketch dimension D in your keyboard, now we can assign a dimension to our sketch objects. Well, it could be 12 centimeter, 120 millimeter. it will be okay to enter your dimensions directly as a, for example, I just need to 12 centimeter. And if I type 12 centimeter cm, it'll directly create 120 millimeter. And also, it's a parametric design. I'm starting to explain a parametric modeling techniques, which is quite important to use your parts as a in the background of the parametric design. Well, normally to create a square, you need the equal. You need to use as a constraint equal for the two points, two lines. There's a way to create that, or you can use these parametric tools like this one. It should be same as the D1 value. When I click that, it will appear directly a function which is follow the first D1 value. Well, if I change it, for example, 150, it will follow the first one. Well, I'm turning back. Now I just want to create an offset. I finished the create section for now, and I move on to modify section. There is a tool, there's an offset. If I select just one line, it will appear an offset session. As you can see, offset line chain, but I just want to 3 lines, not 4. Now you can select the chain selection and deselect this one. Now I'm creating a 10 millimeter or 20 millimeter offset. Nice. As you can see, there is a profile. We can use these profiles to create, to switch to 3D workspace, to use the extrude tool, for example. But in our presentation, it needs to create a new rectangle on the top of the parts, 25 millimeter. Well, I can create rectangle in a short way. The rectangle, the shortcut is generally in the first letter R for the rectangle, or you can use when you see these shortcuts directly, you can create you can modify your shortcuts also. There is a 3 points in there. Change keyboard shortcut. If you like to change your shortcuts, if you want to add new shortcuts, you can use this tool. Now I'm creating new rectangle. I press D button, 25, and now normally I can assign a 120 millimeter directly, but I will show you the constraints. The constraints, which is very handy tool for the sketch workspace, because if you, for example, for these parts, if you use the constant tool, constant constraints for 2 points, I will solve the problem directly, as you can see. I just, but there's a problem. I will return with Ctrl Z because it should be in the first point, like this one, point and point. Now I just finished my sketch. We will switch to 3D workspace. Just you can press just extrude for the extrude tool, E key on your keyboard, and it will appear the extrude tools. You can select the profile, and I will look at my parts as a home tool from there. Now, as you can see in the 3D workspace, you will create your parts as a in the 3D workspace, as you can see. Well, it will be nice to create 400 millimeter for these parts, and I will continue to create to use same sketch for these parts. I will select E key to create the other parts, slider parts, but it is important to change the operation. Well, in the operation tool, it show up as a join, but to create two different components, I have to change like new body or new component. You can directly select new components because we will change, we will modify as a slider mechanism these parts. For example, 30 millimeter, hit the OK button, and in the browser, I can show the components and the body. Well, normally you can rotate these parts because I like to change my 3D workspace to look at my parts. It should be 90-degree rotated for these parts. There is a tool for that. In the modify section, there's a move tool, move copy tool. For example, if I select these parts, there's a manipulator. You can rotate it or move to bodies. You can use these tools, but I like to change the pivot point. Set the pivot as this point and done. Now I change 90-degree. I rotate 90-degree these parts. Well, you can use move copy tool for that. Also, I select M in my keyboard and I change the move objects as a components. Well, you can use the set pivot points for these points, and I change the 90-degree. I rotate it. Now it's done. Well, to switch our presentation, well, Tarek told me a bit difference between components and body, which is great question, and I will explain it in my next points. Well, normally, if I create bodies, like first this part is a body, second part is a body. We cannot assemble it. To use the assemble tools, it should be component. At least one of them should be a component. Because to use the assemble parts, assemble tools, the bodies, it doesn't move, but the components, it can move in the 3D workspace. Well, for that, I also change the two bodies to the components. Well, I will add some details to our projects, but before that, let's assemble parts directly in Fusion. Normally, as I mentioned, if you select these parts and move with your mouse, it will move in 3D workspace because it's a component. If it's a body, it's not move in the 3D workspace. Like this one, it's a body. I tried to move these parts, but I couldn't. Well, now we have at least one component. We can use the joint tool. After I select joint tool, Fusion asked me which point should be a origin point in your parts, in your components. Well, I can select these axis, these edge in these parts, and then I will select these edge. We will create a slider joint in our parts. Well, I select these parts, this point, and which is same edge to the second part. It will automatically select the rigid joints, but I need to change the motion type as a slider. If I change the slider, it will slide in the z-axis, and you can use these parts as has no limit. If you like to add some limits, you can select these parts, or for now it's okay for me, and I select OK. Now I created a project which is include slider joint in Fusion. Well, I need to change some, I need to add some details to these parts. For example, I just need to create a wall to these sides. You can use the sketch and extrude, but there is some different approach to create to modify your parts, to create new parts. Well, in the create section, there's a box. Fusion asked me, you would like to capture the position? Yes, I would like to capture position like that. Well, in this part, I just need to create a box as a wall in here, but these sides, as you can see, there is a different types of operation, like cut operation. Well, I just need to change the operation type as a join, which is quite okay. It will be same as a body one. Okay, that's great. Well, if you like to add some same wall on the other side of the part, you can use same tool, you can use sketch, or you can use the mirror tool. Well, in the mirror tool, in the create tab, there's a mirror tool. Normally, you can duplicate your bodies or faces, components, or features, which is very, very handy. If you select the object type as a features, in the objects, you can select the your features as a box primitive. I selected. Now you just need to create a you just need to select a mirror plane. Well, I just have to have mirror plane in that area. Without a mirror plane, I cannot create new parts on the other sides. Well, for that problem, I just need to create a mid plane between the two end of the two parts, end of these parts and this plane. There is a now mid plane between those parts. Well, if you press the S button, S, to search your toolbox, for example, mirror, I just typed in mirror, and there's a shortcut to use any tool from your Fusion software. Features, as a feature, box feature, and now mirror plane. I have a mirror plane. It will create a new wall to the other side. Well, it looks nice. I just want to add some details to my parts. I will select these parts, V. If you choose fillets for the parts, for example, these parts will be 8. I want to change these. I want to modify these parts as a box primitive. I already selected from there, and I changed the. As you can see, it's not quite same dimension. If I select these parts, it will be a collide, or you can go further. Okay, as you can see, the timeline helps me to modify parts directly in Fusion. Well, I will reselect fillets for these edges, 8 mm, which is quite well, and add some other fillets for here. Well, 10 mm, nice. And also you can modify your second components also. Well, for example, here, and also these parts. If you have a trouble with selecting these two parts, there is another tips for the advanced users. If you press and hold your left click, Fusion show us the all parts, all details in the depth. For example, there's an edge, long edge, and there's an edge, shorter edge. I just want to select the shorter edge. Well, after that, I will deselect the parts and I will change these parts. Now, for the 4 edges, I change the parameters. Well, I also continue to add some other fillets for there. 6 millimeters, 10 millimeters. Nice. Hit the OK button. Well, it looks nice for me. And if you like to add some details here, you can always change and modify your parts whenever you want. Okay. Well, it was the first example for us, and I would like to continue to my presentation. We will see other projects in our Fusion CAD modeling presentation. Well, there's a robotic gripper mechanism. I would like to show you directly in Fusion. Well, before pass this part, I just want to, well, as you can see, you can create some spool gears and modify it to create this robotic gripper arm, which is not so hard to design it, but it should be get knowledge about the mechanism details to create these parts. Because, for example, if you look at the top as a orthographic view, as you can see, there's a line in between the 2 points as an axis, and these ones, it should be exact points, because, for example, you can use these screw and nuts to create, after you manufacture these parts, it should be exactly same spot for the 3 parts, which is quite important, because there's a key holder for the servo motor in the first part, and then there is a second part which is drive the spool gears. Well, after that, you will use the same technique to add some joints to our parts. As you can see, revolt 2, which is drive the servo motor, revolt 3 between the 2 arms, revolt 4 for the spool gears, 4 and 5, and revolve 8, which is connected between the 2 parts. After that, you can create some edit joint limits to limit your parts, like this one. Well, I will go back my presentation. There is a quick animation for this mechanism between these spool gears. Well, I rendered these parts using motion study. Well, in the motion study, you will have a chance to render it in the render workspace, which is honeycomb design for our next example. Let's create in Fusion to get knowledge about the sketch details after the 3D design space. It will be quick. In the sketch model you have different type of design tools like polygon. I select the polygon as a 6 parts. Well, now I just want to create an offset for these parts. Well, if I select the offset, chain selection, now 4 millimeter. As you can see, there's an offset. I'll change the 10 millimeter. Well, now I can use some pattern to create a 10, 20 different but same polygons. And the rectangle pattern, you can select the parts, objects, and it's very easy to create some parts. Well, normally there is a tool as a distribution or spacing. Well, in the spacing, it will be nice to create some exact points after you select your parts. Well, it will be nice for me. I will create the parts as an 8, and in that way you can create new quantities. Well, it looks nice. I'll select OK. And now if you like to create a rectangle for these parts, I will select these 2 parts. The snap points, it will choose 2 points, and I come back to parts. Well, nice. Now I'm choosing offset points. Well, if you like to select these parts, you can select directly from your parts as you wish in this sketch panel, or if you like to create some other patterns for your projects, you can change the sketch model to create these parts using some trim tools or other parts. Well, after you select E tool, well, I'm changing the parts as a well, as you can see, there's a pattern for Fusion. It solves and create these parts. Well, I would like to continue with the mechanism in Fusion 360. Well, normally, if you like to create these parts, you can pattern. You can use the rectangular pattern using just the polygons, and between the polygons, it will be nice to less some gap between the parts, and just create your rectangle. Then you will have a same parts in the end of the session, in the end of the part example. Well, there is another example with mechanism example, planetary gear, I will show you directly in Fusion. Well, in the planetary gear, you can create your spur gear using utilities, add-ins, scripts, and add-ins. There's a quick part creation as a spur gear. If you select the spur gear, create, there will be sorry, it will you just select run for the spur gear. You can add your number of teeth, module, hole diameter. After that, if you select the OK, you will create your parts directly. Because there are lots of details for spur gears, but using these scripts, it will create just few seconds, and you can use this spur gear directly as a component. Well, I'm turning back to my parts. Well, as you can see, the spur gears, it should be same model to join the parts. We'll use the same technique for robotic arm to create the rotate parts for our mechanism. Well, I will continue my presentation. As you can see, there are two spur gears which use the rotate to these parts. Well, there's another CAD modeling examples. If you like to add some rip for your parts, I will show you in Fusion, because there are lots of different tools you can use in Fusion. Well, normally, for example, there's a project. If you like to add some feature as a rip, you can use this rip tool. You just need to add a line to your parts, and after that you'll have a chance to create a feature as a rip. As you can see, it's the same technique for creation these parts. And for these parts, in our next sessions, in our next webinars, we will use these parts to use the static stress tools, the analysis in Fusion. And we will create these parts using technical drawings in Fusion directly. Well, now I would like to explain a robotic arm mechanism and how we can assemble these parts, these axes in Fusion 360, which is quite important because it was a project in a company that used the robots, 6-axis robots, to manipulate the glass plates. Well, in the Fusion, I already created these parts, and I'd like to show you how to assemble these parts in Fusion. Well, normally, as you asked in before, it should be a component for all parts. After you change your module as a component, now you can hit the joint button. For the first parts, normally there are 6 different parts which is component, but I just need to assign a ground parts, which is not changing the position. Normally, it will change the position, but I just want to assign a ground, and after that, it will be not moved, which is quite important for your assembled parts. Now, I'm selecting G for the joint. You have to snap the point for the component 1. Now, you can select the point or a circle, because I just need to create a rotate joint. For this part, I'm selecting, it's not important. It just should be axis references. If you select this circle, which is okay, and I'm looking up there, there is a plus in there. After you select these parts, as you can see, it created a slider, but in my motion type, it should be a revolved to rotate in the z-axis as an orientation. Preview motion. We start with our first parts to rotate the first axis, and it should be 360 a degree, which is quite important for me. It's okay. Now, I will add other joints for my parts. If you select G, normally you can select the points which is plus in there, or directly you can select the circle as you want. Now I'm selecting points. Normally there are some subcomponents in there. It will go just one component, not all the parts, but when you select the OK, it will come all parts at the same time. Now, as you can see, there's just one parts, but after you type the OK, with the all subcomponents, it will come, and as you can see, it starts to move as I created. Now I continue for the third part. I'm selecting last point, and you can select the circular parts. Now it's rotated and the motion. I keep going for the other part. I'm selecting these points and these parts to rotate around that. And now I'm at the last point for these parts. In here. Well, it will finish when I looked at for the parts. I will quickly return back my finished parts, because I already created a motion study to show you how we can add some motion for the parts. Well, after you create all parts, you can assign a motion, which is quite important, because as you can see, for the all revolve joints, there is a value. There is a value as a degree. It will start with the, for example, for the first part, revolve to, it'll start with 0 degree and it finish with the 60 degree. You can add some obstacle geometries, obstacle objects, and you can analyze your all joint parts or all joint values after in these projects. For example, in the company that I worked for creation of these parts, these values it will added directly to the automation parts to manipulate the real robotic arm in our project, which is quite interesting. And for the whole process, the Fusion is very handy, and we created these projects for the from beginning to the all manufacturing parts. After that, the motion study, which is very handy for manipulate these parts. Well, assemble parts. And thank you so much for listening for our first session, first webinars. It will be 6 webinars in total, and you can send me some message using designwagon@gmail.com, or you can follow us from Instagram or YouTube. We are creating some tutorials and clips using 3D design softwares. And thanks a lot for watching these webinars and attending. I just want to ask you, do you have any question or comments about our webinars? I just want to ask you quickly these parts. In the session, Tarek asked me difference between components and bodies. It's the question about the assemblies. And yeah, it's very important because the bodies, it's not moving at all. But we need to at least just one component to start assign a joints for our projects. Well. And for the CAD modeling, to summarize for all parts, all the other projects, it's very easy to start quick projects to create a prototype using Fusion, because in the design workspace, you just need to start to create a sketch and then to switch to 3D workspace, and you can also start to add some joints as we already did, and you can go back to in your timeline to modify these parts. It's quite simple, and it's very handy to manipulate and to manage your projects at the same time. Well. And I will also want to show you a quick reminds. I already share the information. In the CAD modeling workspace, we used always solid modeling workspace. But if you switch the surface modeling, for example, in the surface modeling, I'll erase these parts. As you can see, Fusion starts to think these CAD modeling parts as a surface, which is very, very handy. And now you can create new extrude parts using surface model, which is quite interesting and very handy way to organize and design your parts at the same time. But also you can create form directly, T-spline form in your 3D workspace, and you can modify the parts directly at the same workspace always. And I hope you already used it, or you will use your parts to create some new parts using Fusion. If you have a technical question, just feel free to ask me using this mail or social media account. Well, thanks a lot for attending this session. And Maria, I will let you to screen your share. I'll stop the share for now.
Thank you, Cengiz. I hope that you all learned something from our expert. That was quite informational and educational. So thank you so much. Now I would like to, sorry.
You're welcome.
Now, before we round off, I would like to say about the resources and the software for Autodesk Fusion. So Autodesk Fusion is an integral tool for education, providing students and educators with a comprehensive platform for design, engineering, and innovation. It serves as a bridge between theoretical knowledge and practical application. By visiting the Autodesk education site, you can access a wealth of educational resources, curriculum materials, and opportunities for learning how to leverage Autodesk Fusion in the classroom, helping students develop essential skills for the future. This partnership between education and Autodesk Fusion empowers the next generation of innovators to transform their ideas into reality, fostering creativity and problem solving in various fields. And now I would like to say thank you to all of you for joining us today. Your participation and engagement make these webinars a success. Before we wrap up, I'm excited to share a sneak peek of what's coming up. Our next webinar series, Parametric Design Principles and Design Documentation with Autodesk Fusion, is scheduled for December 6th at 3 p.m. UK time. In this series, we'll be delving into mastering technical drawing details of RC helicopter parts. Please note that this is all being recorded, and after the webinar, the recording will be shared with all of you. Once again, if you have any questions, and also if you have feedback, you can contact me on the email you see here below. But other than that, I would like to say thank you all for being part of today's webinar. We look forward to seeing you at the next one. Until then, take care and have a wonderful day.
Thanks a lot. See you later in the next session.
Thank you. Bye.
Bye.